In this session, we're going to simplify the 1120 test 2 for the year 2024, starting with the first question, which is from exponentials. So they want us to solve this exponential, and it's been allocated 6 marks. Shouldn't take us more than 6 minutes for us to be able to solve it. So the first thing that you need to do is to identify the weird power that you have. The biggest expression here we're having is 8x. So we're going to reduce it to look alike the smaller version, which is e to the power 4x. This can be written as, say, e 4x to the power 2 minus 4 e 4x. This is the same as having a 1 and plus a 3. This is equal to 0. So we can let any letter represent the e to the power 4x. Can let k, for instance, let k be equal to 4 to the power x, meaning k squared minus 4k plus 3 is equal to 0. The whole idea here is for us to have something that will change into a quadratic. That's the reason why we are making e to the power 4x to be the thing that we're going to replace. The first temptation was to think about it in terms of ex, then factorizing 8, and you have 4 ex to the power 4 again, but then that will just take so long. It will still lead you to the same outcome, but it just takes more time. So I'd rather simplify the bigger expression into the smaller one so that they now look alike and we can just replace them with a letter. So this is a quadratic that can be solved the same way you solve all the quadratics. Product sum factor method. This should give us something that looks like this. That's a k plus a 3 is equal to 0. You have k minus 3, and you have negative 1. You have k minus 3. This is equal to a 0. You have k minus 1 and k minus 3, meaning k is equal to 1 and k is equal to a 3. Yeah, so once you get your k values, you need to equate them back to what k was. K is e to the power 4x. This is equal to 1. E to the power 4x is also equal to 3. So this side is easy because we can just let the 1 be the same as e to the power 0. The bases are now the same. We equate the powers. That gives us a 0, meaning x is supposed to be equal to 0. Then this side, the bases cannot be the same, so we're going to introduce ln. Cannot be made alike, sort of. So we can introduce ln on both sides. This is for x, ln e is equal to ln 3. This is a 1 according to the rules of ln. Your 4x is equal to ln 3 divided by 4, divided by 4. So x is equal to ln 3 over 4. This is how question 1 was supposed to be done. You've seen we've done it in 3 minutes. It's just pretty much straightforward. Look at the next one. This guy was carrying 7 marks. They want us to solve a logarithmic expression whose bases are not the same. You're able to see the base here is a 2, the base here is a 4. We have to change the guy with a bigger base to have a smaller base. Yeah, this is going to be, so question 1, part 2 of A. They're saying log 2 x plus 4 minus log 4 27 minus 2x is equal to 0. This here just gives us log 2x plus 4. We change this guy into base 2. That's going to be log the new base. Put the guy that is 27 minus 2x, and we have log the new base, then put the 4 there. This gives us a 0. Remember the rule of changing bases. Whenever you're changing a base of a log, if you have, let's say, log AB, if you want to change this to base x, it's going to be log x the b, this guy here comes there, then you have log, then your base, this a becomes the expression you have there. Yeah, so that's technically what we did here. We want them to have a uniform base. So the down part is going to give us a 2 on the right part. Log of 4 to base 2 is simply a 2. Hope everyone is okay with this, because we say how many times should 2 multiply itself to give us a 4. That's what we mean by log 4 to base 2, right? Yeah, so this is going to give us log of 27 minus 2x to base 2. Down you just have a 2. Now we can do this in an easier way, in a clean way. We can just multiply throughout by 2. That's the best way to go about it, so that we cancel this 2 which is down there. This will be 2 log 2x plus 4 minus log, this is 27 minus 2x is equal to 0. Then from here we can just take the 2 back so that we obey the rules and make this a single quantity. The 2 comes there. We have this 27 minus 2x is equal to 0. The rule says whenever you have log of a minus log of b and the bases are the same, we can just divide these two. This is what we're having. So this guy here is going to just change. We change it from logarithmic form to exponential form. This is going to be x plus 4 to the power 2. Then you have a 27 minus 2x is equal to the power 0. Remember how we do it? If you have log b, y is equal to x, we say b to the power x is equal to y. Yeah, so we say y is equal to b to the power x. The same thing that we've done. 2 to the power 0 is equal to this schema thing that is here. This becomes a 1. We have x plus 4 squared. Down we still have our 27 minus 2x. This is a 1. We cross multiply. This is going to be simplified into a quadratic equation. We have a 27 minus 2x. Expand the left hand side, because 2 to the power 0 is a 1, right? Yeah, then we cross multiply. X squared plus, this is going to be 8x plus 16. So there was a little bit too much to do. No wonder the question is carrying 7 marks. We have 10x. When the 2 comes this side, right? 8x plus that will add. We have a plus 16 minus a 27 is equal to 0. We have x squared plus 10x. So we're going to have a 27 minus 16. Yeah, so 27 minus a 16. This here is a 1. This here is a 1. So this is going to give us 11 is equal to 0. So once we have this, we can evaluate this by doing what? This is going to give us the product is 11. The sum is 10. Now I'm going to be looking for factors. So we can have x squared plus 11. 11x minus factors being 11 and negative 1 plus 11. So from here now we just do the usual way of getting the roots of this guy. How come this is, oh, this was negative here, right? This is supposed to be negative 11. Yeah, this is negative. That's a negative. So that when we factorize, it becomes a positive now. Then from here, we're going to have, there's a 1 here. There's x minus 1 and there's x plus 11. So we solve each of these, first one, and we have the second one, which is this. So we have this guy and we have this. So that answers the question that you have here in terms of getting the two values of x. Now it's just mandatory that when you are done, you need to test in case there's an extraneous solution. A solution which is not satisfying the original question, that's what we call an extraneous solution. So we just try to plug in what we've gotten. So the original question is log 2. There is x plus 4. Then there is a minus log. The base here is 4. There is a 27 minus 2x. This has to give us a 0. So if you plug in 1, that's going to give us log 2, that's a 5. Then minus, we put 1, that's 20, that's log 4. This is supposed to give us what? Is it a 25? Yeah, that gives us a 25, right? Because it's a 1, so that will be a 25. So we can just change this guy into base 2. This is going to be log 225, and that's going to be a 2 down. Yeah, that's going to give us log 25 minus half log 225. Then this is log 25. This is log 25 with a half. That's a 5 there. Okay, so you see that this and this will give us a 0. So 1 is okay. The next thing to check is negative 11. When you put negative 11 there, this is going to give us negative 11 plus 4 here. So this is extraneous. This is not a perfect solution, and this is just the solution. Yeah, so you need to indicate this. So that answers your question number 1A, part 2. The next question is also on logs, just using the laws. They want us to express this as a single logarithm, obeying the rules. Yeah, so you see again the bases are different, so we have to change the bigger base into the smaller base. Yeah, so I'll take it from, this is question 1. This is question 1B. There's 2. And there's a 4. Log 3, there's m. Log 27. M to the power 6. Now this is going to give us 2. I can write a log 3 there, right? By virtue of this guy just being independent, meaning there was a log 3 that became a 1, to multiply it to leave it as a 2, because I need everything to have log. That's the reason why we're doing this. And we're going to have a log 3m. This 4 can go back there. That's going to be m to the power 4. The same way the 2 could have gone back here to give us log 3 to the power 2. That's a 9, right? When this 2 comes back there as a power, we get this. We have log, this is 3, m to the power 4. Then this part here, we have to change it to base 3. That's going to be log 3, m to the power 6. Then we have log 3, 27. This will be log 3, m to the power 6. Log 3, 27 is 3. 3 has to multiply itself 3 times to give us 27, right? So we need this. Then from here, we can now write this as log 3, 9. This is a 9. Plus, that's a log m4. Then plus, this here can be written as 1 over 3 log 3 m to the power 6. So the 1 over 3 can come on the 6 to multiply the 6. So because there's a plus, we're going to multiply these 2. That will be log 3, 9 and m4. Then this is just plus log 3 m. 1 over 3 times 6, that gives us a 2. Because we take the power back, right? It's like we're going to have something like 1 over 3. So 3 there, that's where the 2 is coming from. Yeah, so that's what we have. Then the next thing we're going to get is to multiply these 2 again, because it's 2 addition on the middle. So it's going to be 9 m to the power m to the power 4 times m to the power 2. That's going to give us m to the power 6, because the powers are just going to add. So this is what they wanted us to get. Yeah, that's the best thing that we could have done on this question here, to put it as a single quantity. Then the next one, they're saying find the domain of the function and then sketch the graph. So if we're looking for the domain of a function that looks like this, we're having, this is part C, so this is question 1C. Y is equal to, there's a 1 plus ln, this is 8 minus 4x. So the domain is always going to be this guy here greater than 0, strictly greater than 0. The domain for x should be greater than 0, negative 4x greater than 8, negative, we divide with a negative, divide with a negative, meaning x is actually less than a 2. Yeah, so this is what you have for x. In terms of the domain, it's like negative infinity to 2, and 2 is open because 2 is not included. In short, if we ever want to talk about the vertical asymptote, x is equal to 2 will be the guy that you should never touch. So already what we are having is something that looks like this. The easiest thing here to sketch is, okay, pardon my thing. We're saying we should never touch 2. So 2 is somewhere there. Should never touch it. And if you want to find out where we're crossing the x-axis, you just have to plug in 0 on the other side. So we're going to have 8 minus, is it 2x or 4x? This is 4x. Yeah, this is 4x. So if y is equal to 0, this is going to give us, or we can say, when make a table, x is equal to, and y is equal to, put 0 there, put 0. So now if you want to find out what the value of y becomes when x is equal to 0, we say ln, this is going to give us 8. This is 1 plus ln 8. So when x is 0, y is somewhere there. It's 1 plus ln 8. Then if y is 0, so if y is 0, we're trying to solve. This is ln 8 minus 4x. The 1 can go on the other side. This is ln 8 minus 4x. We change this to exponential. It's going to give us 8 minus 4x. Take this on the other side. It will be 1 over e minus 8 is equal to negative 4x. Then divide by negative 4, divide by negative 4, meaning x is equal to e 1 over e minus 8 over negative 4. Simply put, I can just change this by dividing with the negative. It's 8 minus 1 over e over 4. I just want to get rid of the negative down here, so I'm multiplying everything on top with the negative. Yeah, so that's this number that we're going to have here. This is 8 minus 1 over e. And there's a 4 down. We don't have a calculator to actually know it, but we have it. So we'll have something that looks like this. This is what you get. So that's what your graph is going to look like. This is what you're going to get. So whenever it comes to exponentials or logs, the range here is going to be restricted depending on what you've been given. So in most cases, when it comes to logs, or rather when it comes to, so for ln and log, we normally don't have a horizontal asymptote unless if it comes to exponential expressions, like if this was, let's say, ex plus something, then this would have been a horizontal asymptote, a limit, right? But this guy here will just give us a range. Yeah, so the only thing you have to state here is the range, which is just from negative infinity to positive infinity. It will try to be as big as possible as it moves away from the 1 point ln 8 point this side. So this answers this question, which was just like how many marks? Oh, just 6 marks. Okay. Yeah. I just want the domain specifically and the sketch showing the x and the y intercept. So that marks it for question number 1. Then look at the next question. Given that cos x is equal to negative 3 over 5, and this is from either the first, this 180 to 360, that's going to be the third or the fourth quadrant. The only place where cos is actually negative between these two options, because they've given you a limit here, right? they've said between 180 and 360. So chalk it up to this side. Yeah, the only place we can find cos being negative is per third quadrant. Yeah, so we'll take this case to be happening in the third quadrant, and they want us to get sine 2x and cos 4x. So we have cos. This is question 2. Yeah, this is question 2. So question 2, they're saying cos x is equal to negative 3 over 5. You make a triangle for this guy. Yeah, so the triangle we're going to have is x. Cos is adjacent of hypotenuse, right? And remember, the hypotenuse is always going to be positive, because it's always the biggest, the longest. I mean, this gives us a 4. Using your Pythagoras theorem, we can get sine of x, which is just 4 over 5. Take it as negative because it has to be, since we are dealing with the third quadrant. Yeah, so t fakache negative. Then the other guy is going to be tan, so tan x will be opposite over adjacent. That's going to give us a positive. Yeah, so it doesn't matter how you do your right angle triangle. Even if you did not include a negative 4 here, but polembache sine x, you need to put a negative because this guy here is in the third quadrant. The first part, they want us to get sine 2x. Yeah, so sine 2x, the identity that makes life easier for us here is going to be 2 sine x and cos x. So 2 multiplying sine x, which is negative 4 over 5, and negative 3 over 5. This is going to leave us with, is it a 24 over 25? That's what we should get. Hope this is okay. The next one is asking us to get cos 4x. Part 2, they're saying cos 4x. Cos 4x is the same as cos 2x plus 2x. Meaning this is the same as cos 2x minus sine 2x and sine 2x. So we can just get cos 2x by the side. Cos 2x is the same as what? Cos squared x minus sine squared x. So sine and cos, we got them already. So the cos squared is simply this guy, negative 3 over 5 squared minus the sine squared is negative 4 over 5 squared. Yeah, so this is going to give us a 9 over 25 minus a 16 over 25. This is going to be 9 minus 16. That should give us what? That should give us a 7, is it? Negative 7 over 25. So please check through. I just want to find an expression for this. Negative 7 over 25. And also this is negative 7 over 25. This part here we're having is 24. This is 24 over 25. Yes, it's 24 over 25. This becomes 49 over 25 squared. This here becomes, when you multiply 24 and 24, it should be, is it a 576 or something? Yeah, let me just check it. Okay, yeah, so this is actually a 576 over a 25 squared. So now we're going to get a 25 squared. That should be, is it 625? Yeah, so we have a 625 down there. Then on top we just have a 49 minus 576. So we have 49 minus a 576. That's going to give us a negative 527 over 625. So this is what you get for your cos 4x. Yeah, so please just try to see what we've done here. We've broken it down first into double angles. That's the 2x, 2x. Then I just wanted to solve the cos 2x so that we know what this value is. We got the negative 7 over 25. We're doing the replacement because we do have the sine 2x already. No wonder we just did the substitutions. Yeah, this answers your first question on part 2. The next one is an identity. They want us to be able to prove this identity, to show that the right becomes the left or the left becomes the right. So I'll start with the left hand side because it's a triple angle. It's one that's a little bit big. So this is sine 3x, which is the same as sine 2x plus x. We break down the double angle. This will be sine 2x cos x, then plus sine x and cos 2x. This part is sine x and cos x according to the rules. There's this guy there, sine x. This is the same as 1 minus 2 sine squared. We have 2 sine, this is cos squared, plus this is sine x minus 2 sine to the power 3. Then this is just 2 sine x. This part here is the same as 1 minus sine squared. Then plus a sine x minus a 2 sine cubed x. This will be 2 sine x minus a 2 sine 3x plus sine x and 2 sine 3x. This and this, that's going to be 3 sine x minus this and that, that's minus 4 sine 3. So this is what they wanted. They just wanted us to show that this becomes that or this becomes that. So we started with the left. We've shown that the left can become the right. So it's just all about your rules. It goes back to your rules. If you are really not okay with the rules, you can just try to master these ones here. These are very much enough for you to derive anything you need. Your cos 2x is equal to cos squared x minus sine squared x. Then you have your sine 2x is equal to what? 2 sine x cos x. Together, of course, with the double angle rules, the double angle formulas. This can be modified to either be sine squared 1 minus cos. So we can just make deviations from what you have here. So these are just the most important ones that you need, and those double angles. Yeah, then the part C is requesting us to solve, and if we want to solve a trig equation, we need to make sure that all the trig ratios are in something that's uniform. They are supposed to be the same thing throughout, right? That's what we have. So we can just bring this first part that we're having. This is cos squared. Then we have plus 15x. 15 sine this. There's a plus 6 is equal to 0. So we can change this to be 1 minus sine squared plus 15. Then you have sine x plus 6 is equal to 0. Then this is 2 minus 2 sine squared x plus this guy. So it was easier to change the cos into a sine, unlike trying to change the sine into the cosine, because there's no identity. There is, but then it's going to be a half angle. Yeah, so I'd rather just change this because there's an identity already that can replace the cos squared, and it has sine in it. Yeah, that's what we have. And once you do this, we're going to get negative 2 sine squared x, then plus, this is a 15, then we have sine x, then plus, that's going to give us an 8. Then from here we try to solve this. The product is going to be negative 16. It's just a quadratic, right? Like how you'd solve any other quadratic. So pali sine tifakepoche k. So we're going to say let k be equal to sine x. There's a 15k there. Then there's 8. So we're saying the product is negative. That's AC, right? Negative 16. The sum is just a 15. So what factors can we use? Can we use a what? A 16 and a negative 1. So we have this part. plus a 16k, then plus 8 is equal to 0. This is negative k, remaining with a 2k minus 1. This here is going to give us what? 8, right? We have a 2k, then should be plus here, right? Yeah, that's a plus 1 as well, is equal to 0. That's negative k plus 8. And there is a 2k plus 1 is equal to 0. Then we're going to say k is equal to 8, and here we're going to say k is equal to negative 1 over 2. Now we replace with what the sign is, right? So sine x is equal to 8, meaning x is equal to sine inverse of 8. There's no special angle for this, so we'll go with this other guy. Sine x so we're getting a negative what? A negative half, right? Negative half we're getting the x is equal to sine inverse of negative half. The only special angle that gives us half is 30, but we're not looking for 30 because 30 is in the first quadrant. We're looking for angles of sine where sine is negative because the ratio here was negative. So we're going to add this to 180. That's going to give us what? A 210. And the other place is the fourth quadrant. That's going to give us a 330 when you subtract this from a 360. Yeah, so this answers your question. You can change it to radians if they did or no. The range was in domain, so leave it in. It was in degrees. The domain was in degrees. So leave the answers in degrees. That answers the first part. Then look at the next part here. They're saying state the period, the phase shift, and also the amplitude, the vertical shift. Then we sketch this, right? So I know for this academic year, I was told the part for the phase shift is no longer included, but let's just do it because it's the same thing. It's just something very easy. So question 2, part C3 or C2. Yeah, C2. Question 2. There's y is equal to negative 1 plus cos 3x then minus 60. This here is going to give us what? This here is going to give us the phase shift. So 3x is equal to that guy divided by 3, meaning the phase shift is just going to give us a 20, right? To the right, because it's positive. The period is going to be 360 divided by 3, which turns this into 120. And the vertical shift that we have is just 1, which is downward. There's no amplitude, there's no negative operation, so this is going to have 3 waves. This is cos, right? Yeah, it's cos. So we have 3 waves. There's this first wave in the first 120. There's another one in the second 120, which is landing at 240. Then we have the last one. Then this is a 1, this is a negative 1. We're just saying we need to move this thing by 20 steps to the right. We can just change this. Just add a 20 to 0. Add a 20 to this, it becomes 140. Add a 20 to this, it becomes a 260. Add a 20 to that, it becomes a 380. Meaning we've moved it. These numbers are going to change, right? 120 goes to 140, so I've just not redrawn it. I've just included I've just changed the angles. Then they want the whole thing to be sketched between 20 to 260. That's the range. Here, if you see what they want, this guy. But before we even go anywhere, this has to move down by what? It has to move down by 1 step. So that's literally going to be something that looks like this. If you want, you can just write it like this for the sake of convenience and for you to see what happened. This is 260. This was at 20. This is between 1 and negative 1. And we're moving this thing down by 1 step. So if we move it down, that's going to give us a 0. The 1 plus negative 1, like 1 plus negative 1 becomes 0. Then 0 plus negative 1 becomes negative 1. The negative 1 plus negative 1 becomes negative 2. So the function literally just starts from somewhere here. And also something like that. Yeah. This is 20. This is 140. Then we have a 260 there. This has to look a little bit better. This is our new line of access. That's like the 0 mark. So it's going to be, how do we do it? We say it like this. Okay, something like that. Okay, the whole thing just moves down. Okay, yeah, that's what you get. Close to this. If you're getting this, do mention the domain you've stuck to. We've obeyed the rules to just, and the range has changed. The range is now going to be from -2 to 0. So you need to state this too. It shows that you understand what you're doing. That was question 2. And look at question number 3, which is on binomial. So question 3, they are saying find the coefficient of x to the power 3 in the expansion of this guy. So we're going to take the first part. So question 3, we're having part 1. This is just 1a1 1 minus x to the power 2. Then we have 1 plus 3x to the power -2. Expand this. This gives us 1 minus 2x plus x squared. Then we expand this using the formula. The formula we're going to use is this guy. So the reason why I'm ending here is because everything outside or after the a to the power 2 will be getting us powers that are bigger than 2. We want a term that has x to the power 3, right? Okay, so we have to do that as well. That's going to be 1 minus 2x plus x squared. Then we have, just say 1, -2 multiplying 3x. That's the first and second term. The next one will be -2 minus 1. That's 2 factorial. That's a 2. That's 3x squared. Plus -2, -2 minus 1, and -2 minus 2. Then 3 factorial, that's going to give us a 6. Then we have our 3x to the power 3. Yeah, so once we do that, we can have 1 minus 2x plus x squared. This will be 1 minus 6x. The 2 and the 2 can cancel. That's going to give us a +3. That's going to be what? Yeah, this is a 3, right? A negative with this other negative. This will be a 3. There will be a 3, and there's going to be a 9x squared. That's going to give us a 6. Cancels with that. That's -4. -4 and 27, x to the power 3. 1 minus 2x plus x squared. Then we have a 1 minus 6x plus, that's a 27, x squared minus, we're having 27 multiplied by 4. So 4 by 27, that is 108 x to the power 3. Now we're just going to focus on expanding things that are giving us x to the power 3. So I'll multiply this one and this, that guy. So that's -108 x to the power 3. Again, I'll multiply this guy and that. That's going to give us -54 x to the power 2. Then I'll multiply this guy and that. That's going to be -6 x to the power 3. Just focus on the parts that when multiplied give you x to the power 3. That's what we want. Yeah, so if we want to 108 plus 108 plus 54, then plus a 6. That should be giving us what? 160 168x to the power 3. So this is going to be the coefficient. Negative 168 would have been the coefficient of x to the power 3 in this expansion. Yeah, then look at the next one. The next one, they are saying find the term independent of x in the expansion of. So question 3a, part 2, they're asking us to get the term independent of x. So if we're looking for the term independent of x, we always look for the term that has x to the power 0, the term involving x to the power 0. So this is going to be, this is part 2. So the expression is x to the power 3 plus, this is 2 over x to the power 8. So we're going to use the formula for the nth term, which is n choose r. Then there's a to the power n minus r. Then we have b to the power r. This is equated to x to the power 0. If we do get the r value, we can just add a 1, then we get the nth term. So n is 8. So 8, choose r. The first term is x to the power 3. Then this is 8 minus r. The second term is 2 over x. That's going to be raised to the power r. Equate this to x to the power 0. This is going to be x 24 minus 3r. Then we have 2 to the power r. Then there's x to the power r is equal to x to the power 0. Then from here, we have x 24 minus 2r over x to the power r is equal to x to the power 0. Then this is equal to x 24 minus 2r minus r is equal to x to the power 0. And this just becomes 24 minus 3r is equal to 0. This is negative 3r is equal to a negative 24. Divide by this, divide by that. So r gives us 8, is it? Once you get your r, you can replace it in this expression to get the value of the term. So this is the 9th term. It is the 9th term that is independent of x. We have to actually get it. Yeah, so we say we have, this is 8, right? This is 8, choose 8. Then this is going to give us what? X to the power 3. This is 8 minus 8. That's going to give us, was this 8 or 12? Where did I get the 12 from? Okay, it's 8. So 3 by this, okay, yeah. That's negative 3. Okay, let's just check. That's going to be 8 minus 8, that's a 0. Then this side you have what? You have, this is supposed to be 8 minus 8, right? We're having this part. Let's see where I have gone wrong. We're saying 8. This is, yeah, 8 choose r. This is what we're having, right? There's this guy down there. Okay. This is a 3r. Yeah, so I made a mistake on the 2. Yeah, this has to be a 3 so that we can get, this is now a 4r because it's this guy, yeah. So we're going to have 24 minus 4r is equal to 0. Then negative 4r is equal to negative 24, meaning r is equal to 6, right? So it's the 7th term. So r is 6. Yeah, so we have this. That's a 6 plus 1, meaning this is the 7th term. Then we're going to replace, right? It has to make sense. No, it's important to get it. So we put the 6 there. This is going to be a 2. That's going to be what? 2 over x to the power 6. 8 choose 6. 6, this is 2 to the power 6, x to the power 6. You're seeing this cancelling. This is just 8 factor, 2 factor, and 6 factor, multiplying 2 to the power 6. So this 2 can cancel with 1, 2 there, leaving us with 8 times 7 times 6 factorial. There's a 6 factorial down. This is 2 to the power 5. This cancels. The final answer is just 8 by 7 by 32. Yeah, so this is going to give you your answer. You can multiply this. That's a constant, right? That's the 7th term that they wanted. Then look at part B of question 3. Yeah, so part B says, when 1 plus bx to the power n is expanded in the ascending powers of x, the coefficients of x and x squared are negative 16 and 24 respectively. Find the values of b and n. Find the coefficient of x to the power 4. So they said in the ascending powers of x. So I'm going to take the best case scenario, assuming that our n is supposed to be negative. So I'll just start with that. Let me see. Let's see, it's negative or no. Let's see, this has to be positive, right? So let's see. Let's give it a try. We have question, since this is 3b. So they're saying we have 1 plus bx to the power n. When we say n, choose r of 1 n minus r bx to the power r. We need to get the coefficient of x squared is what? I mean x. They're saying is negative 6, negative 6x. Then again we do the same thing. That's n choose r. 1 n minus r. Then bx to the power r again. Equate this to 24x squared. So we've made two equations, right? This guy and this guy. It's like we're looking for the nth term, the term involving x and the term involving x squared. Then from here, we can cancel this part because it's irrelevant. The 1 won't change anything. So this part can be ignored. This part can be ignored. So I can just erase this part and erase this part. In your case, you'd have to rewrite these again, just the guys without this middle part. So it will be like this. Then if you look at this first equation, get the portion that has x, also get the portion that has x. It tells you that x to the power r is equal to x, meaning r is equal to what? 1, right? Here, get the portion that has x, get the portion that has x this side. Already, r gives you what? A 2. So we're going to replace r is equal to 1 in the original equation. That's going to be n choose 1. Then I'm having a bx to the power 1 is equal to negative 6. And this side I'm having n choose 2. This is a bx to the power 2 is equal to 24x squared. We'll solve these guys together. That's going to be n choose 1 multiplying b is equal to 6, negative 6. N choose 2 multiplying b squared is giving us a 24. Ignore the x parts. Just focus on everything else but not x. Yeah, so we have this. This here is the same as n choose n factorial. Then you have n minus 1 factorial. Then you have 1 factorial. This is times b is equal to 6. This side you have n factorial. You have n minus 2 factorial. You have 2 factorial. B squared is equal to a 24. Well, this is a negative 6. Now you're able to see that the middle, the guy here can be written as what? This guy here can be written as n minus 1. Then the guy down is n minus 1 factorial. There's a b there is equal to negative 6. Here we can just have n. Then you have n minus 1 and you can have n minus 2 n there. Down you have n minus 2 factorial and a 2. There's a b, right? A b squared. This should give us a 24. So here you're going to cancel that, meaning nb is equal to negative 6. Then here again we're going to cancel this. Then we have b squared, there's n and n minus 1 over a 2 should give us a 24. Now we can multiply this part, this guy here. I'm going to get b squared and n squared minus b squared and n. This is equal to 48 when you cross multiply as well. So here I can have nb squared and this bn with an extra b. This is 48. We know to say nb is negative 6. So where there's nb, we can put negative 6 minus negative 6. This is a b is equal to 48. That's a 36 plus 6b is equal to 48. We have 6b is equal to 48 minus 36. That's going to give us a 12. Yeah, so 6 there. So b is equal to 2. Once you get your b, remember we said nb is negative 6. Put your 2 there. That's 2n is equal to negative 6. Divide by 2, divide by 2. So n is equal to negative 3. Yeah, so we've gotten our n and our b. So just try to replay it back slowly to see what we've done. We equated the expressions first, found the values of r, replaced them, and solved to simplify each part, then equated nb to negative 6 and replaced it in the other expression. So that's how we ended up getting these two. Yeah, so our n is negative 3 and our b is a 2. So that's what we get for this part. Now, if you know your n, because now we know our n, we're saying our n is negative 3, right? Our n is negative 3. So here we're saying our n is negative 3. Then they're saying we find the coefficient of x to the power this. So we're having n. No, n has to be, where is the b? Let me see, just a minute. So our n being a negative 3 is contradicting everything. So let me just try to redo it again. Because the power has to either be a positive or negative. Now if they say expanded in the ascending powers of x, so we can say, let's try to use this. Let's see what we get if this is going to be proper. 1 plus n bx n and n minus 1 over 2 bx squared. Then we're going to get what? It goes on and on, right? Remember how this formula goes on and on. There's a 3 factorial here, which is just a 6. Then you have bx to the power 3. The next one will be n minus 1, n minus 2, and n minus 3. There's a bx to the power 4 over 4 factorial, which is just what, a 24, right? So if we take this to be negative 6, nb to be negative 6, that's what we're going to take it as. Then here, this whole part is n minus 1, there is a 2, then there's a b squared. We're saying this is what? 24, because that's a coefficient. That's what's in front of x squared. Then if we solve it like this, it should make sense. Cross multiply, that's going to be n squared and n. There's a b outside. This is 48. This is going to be b squared n squared minus n and b squared is equal to 48. So we're going to have bn squared, then this is nb, then there's a b is equal to 48. This here is negative 6. We square it. There's a negative 6 there. Let me just see if I did it wrong. There's a 36. That's going to be plus 6b. This is 48. So 6b is the one. We got b first. B is the guy that's 48 minus 36 over 6 over 6. Meaning b is equal to, that's a 12 over 6, meaning b is a 2. So if b is a 2, we replace it back in nb is equal to negative 6. Put b there, right? So we're going to say 2n negative negative 6, 2, 2. N is equal to negative 3, yeah. So meaning the expansion was supposed to look like this because the first term is 1 and they said ascending powers. So it was supposed to be expanded using a case when the power is negative a fraction. That's what we anticipate. We use this. So that answers the first part. Yeah, so this is done. Your N is negative 3, your B is 2. They ask for the term that the coefficient of x to the power 4 would just replace in this is the term they're asking for. Yeah, so meaning Pali N will put negative 3. Just put negative 3 there. Negative 3 minus 1, then negative 3 minus 2, then negative 3 minus 3. B is what? B is the same as 2, right? So 2 to the power 4, because bx to the power 4, meaning the 4 affects everything. So that's 2 to the power 4, everything over your 24. Yeah, so you can just solve this. It will give you the number that is needed for the second part as a coefficient, which should be something like what, when you're done, this is going to be what, a 24. You can just simplify it. That's negative 3, that's negative 4, that's negative 5, that's negative 6, 2 to the power 4, that should be a 16. Yeah, then over a 24. Then we try to reduce this. This is a 12. 12 there gives us a 2. 2 there is 8. So we're just literally going to have 5 by 8, then by 6. This is a 40. 6 by this, that's going to give us a 240. Yeah, so the answer is 240. Yeah, that answers this question. So we're done with it. Look at the last part here. They are saying we have what? It has to be broken down into partial fractions, and the first temptation was to use case 1 because you are seeing the guys down a linear factors, right? Which is going to be wrong, because if you expand the down part, it's going to give you the same degree as the numerator, meaning this is actually an improper case. I'll say that again. You are seeing 7x squared plus 14x then minus 12. The guy down is x minus 1 and there's x plus 2. The first temptation is for you to think this is just going to be x minus 1 plus b and you have x plus 1. To assume this is like case 1. So we cannot do that because you're able to see that the down part is also a quadratic. They are going to have the same degree, meaning we just have to expand the down part. We write this for you to be able to see it. So the down part, x times x, that's x squared. Then you have plus 2x minus x minus 2. So you have what? You have 7x squared plus 14x minus 12. The down part is x squared plus x minus 2. You are seeing they're the same degree, right? This is case 4 when you're dealing with an improper case. So we're supposed to use long division first. So long division first. We have x squared. This is the part where most people got this question wrong because they used case 1 and they were failing to find the values of a and b because it cannot be done because it's an improper case. This would give us a 7x squared plus 7x minus a 14. This is going to be a 7x. We're having what? This is going to be a 2, right? Yeah. So we're just saying the whole expression now has been simplified a little bit. We have 7x squared then plus 14x plus a 12 divided by these two. I'll put them the way they were, which is x plus 2. When we divide this into that, it gives us a 7 plus the remainder is this guy, which is at least at a lesser degree. We have x minus 1 and you have x plus 2. Now this is the part that you're going to write in partial fractions. It's not yet done. We have to break this now into partial fractions. Yeah, so now we're just using case 1. This is now 7 plus 7x plus 2 x minus 1 and x plus 2. I'm just saying this is going to be equate this portion alone. The 7 will be waiting a x minus 1, then plus b and x plus 2. Yeah, so we can just break this guy down. That's a 7x plus 2, or just go direct x plus 2, and you have your b x minus 1. So you can try to pause the video and try to get the a and the b. We'll see if we get the same numbers. So this is now going to be the same as 7x plus 2. This is, I'll use the shortcut. Where there is, solve the first guy down, this gives you x is equal to 1, right? Wherever there's x, put a 1. This is going to give us a 9 this side and a 3a, meaning a is just equal to 3. So we solve the first factor. That's where the x is equal to 1 came from. Replace this wherever there's x in this expression. Yeah, so that's where this came from. Because this becomes a 0, you get your a to be that. Solve the second factor, which will give you x is equal to negative 2. Replace wherever there's x, put a negative 2. That's going to give us negative 2 by 7. That's going to give us a negative 12. Goes to be negative 14 plus 2. That's negative 12. Then this side is negative 3b. So meaning b is just going to be a 4. Yeah. So this whole thing has been broken down. The answer will be 7 plus a was 3 over x minus 1 plus b was 4 over x plus 2. So this is how we're supposed to do the function, breaking it down into partial fractions. Then they are now concluding the statement by saying, expand this when you're done to give you the term that has x to the power 3. Right? That's what they want. So this was a bit interesting. So if you don't get this part, meaning the other working will just be wrong. This was supposed to be now rewritten as something that looks like this. The negative 1, 4, and x plus 2 with a negative 1. We can change this to be 3x minus 1, or change this guy here. Yeah, change this, switch them up. That's going to be, say what, how can I say it? Negative. That's going to be negative 1, then plus x. I'm just switching them up. This is 4, this is going to be 2 plus x. Negative 1. The reason why we're doing this is because we cannot use the formula, the expansion, without the first term being 1. So that's the reason why we're doing this. Yeah, so we're going to have, this part is going to be a 7. This is a 3. This gives us what? This is going to give us a negative 1 to the power negative 1. Okay, this will make things interesting. Then we have 1 minus x to the power negative 1. So I'm factorizing negative 1 here because we said the condition has to be this. So please look again here, guys. Look here. So I didn't do anything unique at this point, in case maybe someone is having challenges understanding what is happening here. This is x minus 1. I just switched them up. This is negative 1 plus x. Then from here now, I'm having negative 1 plus x. How do I factorize this? I want to factorize the negative outside. Yeah, so we're going to have negative 1. Then we're going to have 1 minus x. That's what we have. So from here, we're going to include the power, because this thing had a power which is a negative 1. So we need to include the power, distribute it on both guys. That's where the 7 plus 3 negative 1 to the power negative 1 and 1 minus x to the power negative 1 came from. Then 4, this one here is just going to be a 2 outside with a negative. Then this is just 1 plus x over a 2 to the power negative 1. To write this in a normal way, I'm just going to say this is the same as a negative 3, 1 minus x, the power that, this is just going to be 2, because this is the same as half. Then half of 4, that's a 2. 1 plus x over 2, negative 1. Then from here, we're just having 1. This is, expand this, that's going to be 1. Negative x and negative 1. Then I'm having a negative 1 and negative 1 minus 1, 2, negative x squared. The wanted term that has what? The wanted term that has x to the power 3. Okay. Shit, okay, this is going to be long. Then we have plus negative 1, negative 2. I'll do it fast. That's 3 factorial. That's negative x to the power 3. We'll end there. The next part, there's a plus. There's this part as well. There's 2. Then there's 1, half of this guy, plus negative 1 and negative 2. There's a 2, x over 2 squared. Negative 1, negative 2, negative 3. There's a 6, that's 3 factorial. X over 2 to the power 3. And this is going to be a 7 minus 3. So we're going to just simplify this part. So if I do the simplification, I'm just going to get a 1 plus x. This here is going to be negative 1 and negative 2. So this is just a 2. It goes away. This is x squared. This here gives us a 6, which is going to come out negative and the negative. So that's going to be positive x to the power 3. Okay. So please look at it again. Negative, negative, negative. That's going to be negative 6. Plus the 6 there, they cancel. But there's a negative coming out from here, cancelling with it. Yeah. Then the other part is 2. This other guy here. There is 1 minus this guy. This goes away. That's just going to be x squared over 2. Or 4, I mean. 4, 4, 4, 4. Because even the 2 down has to be squared. And here we have a 6, right? Cancelling with that part. This is going to give us a negative x to the power 3 over 8. Okay, this is nice. From here, we're going to have 7 minus 3x minus 3. Minus 3x is here. Minus 3x squared minus 3x to the power 3. Then this is plus 2x plus x squared over 2 minus x3 over 4. We're adding terms that have x to the power 3. That's what we want. They just want the term that has x to the power 3. We'll focus on this guy, focus on that guy. Negative 3x to the power 3 minus x3 and a 4. Sum up this. So this is going to be a negative 4 of x to the power 3 minus x to the power 3. Yeah, so this is going to be a negative 13 4 and x to the power 3. So the coefficient is negative 13 over 4. Oh, up to, they were just expanding, sorry, not the coefficient or whatsoever. So we're expanding, right? We're not even getting the coefficient. They just wanted the up to x to the power 3, right? Yeah, okay, my bad. This has to be 7 minus this guy, that's a 4. So they just want this part. Okay, the 7 minus 3, the like terms in terms of the constants. So we have this part, that's a 9, that's a 6. Then we have this and that, that's negative 4x. We have this guy and that guy. That's going to give us negative, this is negative 3 minus half. That gives us 2.5, right? So this is just 5 over 2 x squared. Then this and this, we're from getting it, is negative 13 over 4x to the power 3. That's the answer that they wanted. This answers your question number 3. Okay, that was a little bit too long. Then look at the last part. This is very, very simple. Calculus, they say in each of the following, in each of the cases below, evaluate the limit if it exists, right? Okay, so when they say the limit as x approaches 4, for x minus 4 and x cubed minus 64, but for a1, as x approaches 4, we have x minus 4, then we have x cubed minus 64. So you notice that when you put the 4, this whole thing becomes 0 over 0, right? Yeah, and we don't want to do that. So the best thing to do here, since you've done differentiation, I'll give you method 1. The first method you can do is just to differentiate the top part. That's going to give you the limit as x approaches 4. That's a 1, right? Differentiate the top part, that's a 1. The derivative of the down part is 3x squared. Then now plug in your 4. That's going to be 1. 3, 4 squared. This gives you 1. That's going to give us a 3. A 3 by 16, that gives us what? Is it a 1 over 48? Is it? Yeah, something like that. Now this is only if you are, let's say, running out of time, you can do this method. This is called L'Hopital's rule, where we are avoiding a 0 over 0 case by getting the derivatives of the numerator and the denominator to eliminate the component which was making both of them to be zeros. Or you could have gone it via method 2, the longer route. Yeah, and this was just requesting us to do it in how many marks? This is okay, 5, 5. So we'll prefer method 2 because of the marks that we indicated. So method 2 is simply going to be, we get our x to the power 3 minus 64. First of all, we expand it. That's going to be 0x squared and 0x minus 64. Then the coefficients are 0, 0 and negative 64. The number we're approaching is what? Is 4, right? So we put the 4 there. This is going to be what? This is going to be 1. That's a 4. That's a 4. That's a 16. That's a 16. That's a 4. Sorry. That's going to be 4 by 16. 4 by 16. That should give us a 64, if I'm not wrong. That should be a 0, implying that the limit as x approaches 4 of x minus 4 is the same as x minus 4 and the quotient, which is x squared plus 4x plus 16. Then we cancel this and cancel that. There's a 1 there. The limit as x approaches 4, we have 1 x squared 4x plus 16. Plug in the 4 now. This is going to give you a 4 squared plus a 16, another 16. Still gives us the same outcome, which is 1 over 48. So that's how you're supposed to handle this guy. Yeah. Then look at the next one. We're approaching a negative 4, and we have a third down in the denominator. So here we're going to rationalize the denominator. This becomes as follows. We have the limit as x approaches negative 3 of 2x plus 6. The down part is negative 3 plus root of 6 minus x. So rationalize, multiply by the conjugate. Multiply with the conjugate, 6 minus x. We have the limit as x approaches negative 3. We multiply this, that's going to be 2x plus 6. Then we have negative 3 minus root of 6 minus x. The whole lot of the down part is just negative 3 times negative 3, that's a 9, minus your 6 minus 3, minus x, I mean. Yeah, so this is going to give us the limit as x approaches negative 3. We have 2x plus 6, and we have negative 3 minus. This is 9 minus 6, then plus x. This is going to give us the limit as x minus this. I can factorize a 2, that's x plus 3 on top. Then you have negative this minus this part. You notice here you are getting what? You are getting a 3 plus x. Cancel this and cancel that. Then this will give us the limit as x approaches negative 3 of 2 negative 3 minus 6 minus x over 1. There's no need of putting the 1. We can now just replace wherever there's x, put your negative 3. That's going to be negative 3 minus 6 negative 3, like this. Yeah, so this is going to be 2 negative 3 minus, that's a 9, minus a 3. This gives us a 2. This gives us a 12. So that's the limit that we wanted. So that's how we're supposed to do question 4a, which involves limits. The whole idea why we had to go through this route is because if you replace negative 3 there, the top part becomes 0, even the down part becomes 0. So we don't like getting the case 0 over 0 because it is undefined. We're unable to evaluate it. Then part 4b, they're saying differentiate using first principles. There's f of x, which is 2x to the power 3 minus a 7x. So here we'll say the limit, the derivative is just the limit as h approaches 0 of f of x plus h minus f of x. Then down we just have h. This is the limit as h approaches 0. We replace wherever there's x, we put x plus h in the function. So that's going to be 2x plus h to the power 3 minus a 7 with an x plus h as well. Put this in brackets because this has to subtract the original function, which is 2x to the power 3 minus a 7x. Everything down has an h. Then from here, we'll say the limit as h approaches 0. This is going to be a 2x squared. When you expand, we're expanding this, right, using your binomial. That's going to be using the Pascal's triangle. This is supposed to give you something like a 3x to the power 3 squared. Then we have plus, this is 3x and h squared, then plus, this is going to be h to the power 3. This is going to give us a negative 7x minus 7h. Then we're having what? Minus 2x3 plus a 7x. Down we just have our h. So this is going to be the limit as h approaches 0. This is 2x to the power 3 plus 6x squared h plus 6x h squared plus 2h3 minus 7x. Okay, so the 2 just has to multiply this capacity up to there. So that's why the 2 has to multiply. This was outside, yeah, so we just need to write it the way it is. Minus 2x squared plus 7x. Everything over h. You're able to see that this subtracts with that. This goes away with that. So now we are having the limit as h approaches 0. We have 6x squared h, 6x h squared plus 2h3 minus 7h. Everything over an h. We have the limit as h approaches 0. H there is factorized. 6h, then we have 2h squared, or even the 7 as well, sorry. Minus a 7. Down we have an h. This cancels. So we can now plug in wherever there's h, put your 0. Everything becomes 0 there. That becomes 0 minus 7. The final answer is 6x squared minus 7. That's how we're supposed to get it. And it makes sense because if you use the power rule, that's literally what we're going to get. Yeah, so that's okay. Then part C. I prefer the black guy. So part C is also asking us to differentiate, and here we're going to apply chain rule because the power is weird and we are unable to evaluate it using other means. So this is for C. The first one is y is equal to the root of 1 minus 4x plus 3x squared. So this carries 4 marks, so the proper way to show it, I'll show you the standard way to do it here. 4x then plus 3x squared, the power half. You let the inside part be equal to u, this part here, that's a 1 minus 4x then plus 3x squared, meaning y is now u to the power half. You differentiate this, dy dx is equal to half, or dy du, right? This side is dy du. The letter here is y, then this is u. Yeah, this is u negative half. And here you have du dx. Du dx will just be negative 4 plus 6x. So to get dy dx, we have to multiply du dx and dy du. So dy dx is equal to this 4 plus 6x multiplying half. Then there's a u to the power negative half. You can just replace, this is half negative 4 plus 6x. Replace what you had. So our u was 1 minus 4x then plus 3x squared to the power negative half. So this is what you get as a derivative. Of course, you could have simplified it. Half can reduce this to be negative 2 plus 3x. Then this is multiplying 1 4x plus 3x squared to the power negative half. So that's what you get as the derivative of the first guy. Then look at this interesting guy here, the last one, tan to the power 7. This is what you have. Again, we're going to use chain rule. That's y is equal to tan to the power 7. This is 2x minus, like this, yeah, 2x squared minus x. So you let y be equal to tan 2x minus x. You let this whole thing be equal to 7 because we want to apply chain rule, right? Then you let this whole thing here, let u be equal to the inside part. That's tan 2x squared minus x. That's the best way to do it, meaning y is equal to u to the power 7 and u is equal to tan 2x squared minus x. So you know to say if you want to differentiate dy du, this is just 7u to the power 6. Differentiate du dx is going to be, differentiate what's inside here, that's a rule, it will be 4x minus 1. The derivative of tan is x squared, right, of whatsoever was there, that's 2x squared minus x. So we're just going to multiply these two now, this guy times this. This is going to be dy dx is equal to 7, 4x minus 1, then you have sec squared, 2x squared minus x, then we have u to the power 6. U, remember what u is? U is tan 2x squared minus x. This whole guy to the power 6. We can write it in a better form. This is 7, 4x minus 1, sec squared. There's a 2x squared minus x. This is the same as tan to the power 6, 2x squared minus this. This is what we get as the derivative. Yeah, so this brings us to the end of last year's assessment. It was a little bit interesting. You notice I've taken a bit longer than usual on solving test. Yeah, so thank you so much for your attention. Please feel free to WhatsApp if you have any questions.